Nomenclature of polysubstituted benzenes. When you have more than one substituent present on the benzene ring, then you have to list all substituents in alphabetical order, making sure that they get the lowest possible number. Here we have three substituents, but out of these two substituents are closer to each other, right? Therefore, you have to assign one of these to be number 1. We are going to assign this carbon where the nitro group is attached as number 1. So we can go on to bromine. This will be 2, and then reach the third substituent with the shortest distance. So 2, 3, 4. So here we have bromo, chloro, and the nitro group. And you can see that all of these are merely substituents and not functional groups. In that case, they are not going to get any special preference, except that they are going to get arranged alphabetically. So the name for this compound is 2-bromo, 4-chloro, 1-nitrobenzene. Let's go on to the next example. Here again, we only have the substituents. We do not have any functional groups. So here again, there is no any particular preference except that they should be arranged in alphabetical order. Here, we needed to choose one of these to be 1, right? One of these groups to be 1. So if you're going to choose this one as number 1, then let's see what would be the numbering. 1, 2, 3, 4. So we get the number 1, 2, 4. But if we go in the other direction, let's say that you're going to choose this carbon to be number 1. Okay. I'm going to use a different color here. This carbon is number 1. And then obviously you have to go in this direction, right? So that would be 2, 3, 4, 5. So that would be 1, 2, 5. Obviously 1, 2, 4 is a smaller number than 1, 2, 5. So you have to stick with this, where you're going to assign this carbon to be number 1 and go in the anticlockwise direction to reach the second and the third substituents. So it would not be 1, 2, 5, it will be simply 1, 2, 4, right? So let's write the name for this compound. So it would be 4-bromo, 1-chloro, 2-nitrobenzene. And you can see that they are arranged in alphabetical order. Let's go on to the next compound. These are basically constitutional isomers. All of these are constitutional isomers, right? So let's go on to the next compound. So here we needed to assign one of these to be number 1. So we can assign this to be number 1, right? And this carbon, we have to go in the clockwise direction here, 2, 3, 4. And therefore this should be 1-bromo, 4-chloro, 2-nitrobenzene. Let's go on to the next compound. On the next compound, we do have a carboxylic acid functional group. So this is a carboxylic acid functional group. And by default, this carbon, where the carboxylic acid is attached, will be 1. And we have to reach the second and the third substituent with the shortest distance. So now if you go in this direction, then it puts the bromine in the 3rd position, and the nitro group will be in the 6th position. So let's have the numbers here, 1, 3, 6. But if you go in the other direction, let's see what's going to happen if you go in the other direction, 2, 3, 4, 5. So you're able to get 1, 2, 5. Obviously, this is a smaller number when compared to this. So therefore, this is accepted. And we should cross this one off. This is not going to be appropriate numbers. When you have a carboxylic acid functional group that is directly attached to the benzene ring, then you don't have to give the number 1 when writing down the name. So this should be simply called as benzoic acid. Okay, so that would be the parent name for this compound. So this part right here is benzoic acid. So leaving that benzoic acid, we do have a nitro group and a bromine. And these are situated at position 2 and position 5 respectively. So let's arrange them in alphabetical order. Obviously B comes first. So it will be 5-bromo, 2-nitro, benzoic acid. That would be the name for this compound. Let's go on to the next problem. Here we do have functional group, hydroxy group. By default, this carbon right here will be number 1, and you have to reach the second and the third substituent with the shortest distance. You cannot go in this direction Instead, you have to go in the anticlockwise direction. So 2, 3, 4, and that would be 3-bromo, 4-chlorophenol. Since we have talked earlier that when you have an hydroxy group that is directly attached to the benzene structure, then it's a phenol, right? So this part right here will be called as a phenol. That would be the parent name. Let's go on to the last structure we have here in this slide. When you have an amino group attached to the benzene molecule, benzene ring structure, then it's called as aniline. By default, this carbon will be number 1. Right? And when you have two groups that are closer to each other, you have to choose one of those, right? And because you have the functional group here, by default, this will be number 1. And since you have a group adjacent to it, you have to call this as number 2. Right? Go in the other direction to reach I. Go in this direction to reach I. And this would be 2-ethyl 4-iodoaniline. And again, they are alphabetized. Aniline is this part of the molecule. So when you have this benzene ring and the NH2 together. This is an example for phenol. You can see that this is the phenol structure. And on phenol is present an isopropyl group. This one right here is an isopropyl group. And we also have a methyl group. So obviously this carbon will be number 1. And you have to choose, you're going to choose the next substituent with the shortest distance, right? So this is obviously 2. And then you have to reach the third substituent. So the name for this would be 2-isopropyl 5-methyl phenol. That would be the name for this. Let's give the name for this next molecule. But the next molecule is so special because it has got 2 functional groups, right? So we do have an hydroxy group and we also have an aldehyde functional group. Now between these two, we needed to assign a priority first, right? We have to look into the priority chart and find out which one has got more, which one has got the highest priority. Here is the priority chart for the different functional group. You can see here the alcohol is here and the aldehyde is 2 steps up from alcohol. So by default, this carbon where the aldehyde is attached should be number 1. Okay. So let's assign this to be number 1, and you have to reach the second and third substituent with the shortest distance. So 2, 3, 4. And since you have this aldehyde group directly attached to the benzene molecule, it's called as benzaldehyde, right? And this should be named as hydroxy group, and this should be methoxy, right? And they are in 4th and 3rd position respectively. So H is going to come first, and therefore this should be 4-hydroxy 3-methoxy benzaldehyde. That would be the appropriate name for this compound.